What if the one weapon Iran counted on for 30 years to hold the world hostage just became worthless in a single night? And what if the people who built that strategy realized, far too late, that the math no longer works in their favor? This is not speculation. It is happening right now in the most dangerous stretch of water on the planet. Before we get into the details, if you care about global power shifts, military technology, and the future of warfare, hit that subscribe button and turn on the bell. This is the kind of analysis you will not find anywhere else, and sharing it with someone who needs to hear it truly helps the channel grow. The Strait of Hormuz is 21 nautical miles wide at its narrowest point. Every day, roughly 20% of the world's oil passes through that corridor. For decades, that fact gave Iran enormous leverage. The country never needed to defeat the United States Navy in a traditional sense. It only needed to make the cost of operating in the Gulf so high, so exhausting, and so financially devastating that Washington would eventually choose diplomacy over indefinite military commitment. That strategy had a name, and it was genuinely brilliant. It was called the Swarm Doctrine. Here's how the logic worked. Iran's military planners understood something that most outsiders completely missed. A Shahed 136 drone, one of Iran's primary attack weapons, cost roughly $20,000 to build. Now, think about what it costs to shoot one down. An AIM-9X Sidewinder missile costs about $400,000. A rolling airframe missile costs close to $1 million. A standard SM-2 interceptor can cost $2 million or more. Every time Iran launched a cheap drone and an American warship fired an expensive missile to stop it, the exchange was devastating for the defender. Iran was spending a few $1,000s. The United States was spending hundreds of thousands, sometimes millions, to neutralize a single threat. The ratio ranged from 20 to 1 all the way to 100 to 1 in Iran's favor. But the financial damage was only part of the trap. The deeper problem was physical, and it was built into the very design of every American destroyer in the fleet. Every Arleigh Burke-class destroyer carries a fixed number of interceptor missiles loaded into its vertical launch cells before it leaves port. Once those cells are empty, the ship must return to port for resupply. That process does not take hours. It takes days. During that resupply window, the warship is effectively blind and defenseless, unable to protect the commercial vessels it is escorting or even defend itself. Iran's swarm doctrine was engineered precisely around that constraint. The goal was never to sink American ships in some dramatic single battle. The goal was to launch overwhelming numbers of cheap threats, drones, fast attack boats, cruise missiles, all at the same time across multiple directions. Each interceptor fired to stop a threat reduced the ship's remaining supply. The objective was simple mathematics applied over time. Drain the magazine, force the withdrawal, exploit the gap, repeat the cycle. Slowly, steadily, make defending the Gulf so expensive and so exhausting that the cost-benefit calculation in Washington would tilt toward negotiation. For 30 years, that strategy had real teeth. American naval planners ran the numbers and did not enjoy the results. The economic asymmetry was real. The magazine depth constraint was real. The resupply vulnerability was real, and it could not be engineered away easily because it is a fundamental physical limitation of missile-based defense. Iran had discovered a genuine lever, a mathematical advantage that made asymmetric warfare against the most powerful navy in human history a viable long-term approach. It was elegant, it was patient, and it was working. And then, something changed. A single system arrived on the deck of the USS Pinckney, an Arleigh Burke-class guided missile destroyer, as it moved into operational position in the Strait of Hormuz. Its name is HELIOS, which stands for High Energy Laser with Integrated Optical Dazzler and Surveillance. What HELIOS does to 30 years of Iranian strategic planning is not complicated, but it is absolute. It does not weaken the swarm doctrine at the margins. It does not reduce its effectiveness by some percentage. It makes the entire economic and operational foundation of that doctrine collapse completely. Here is why. Every weapon a destroyer normally carries fires a physical object. A missile leaves the launch tube, travels through the air, and reaches its target after a measurable period of time, even if that time is only seconds. Iran's fast attack boats were specifically designed to exploit those seconds through sharp, evasive maneuvers. Iran's drones were built with electronic countermeasures that activate during the missile's flight window. The radar-scattering hull shapes on Iran's boats were engineered to confuse fire control systems during the terminal phase of an interceptor's approach. 3 decades of tactical development, all of it built around exploiting the gap between the moment a weapon is fired and the moment it arrives. HELIOS fires a beam of focused energy that travels at the speed of light. At the engagement distances inside the Strait of Hormuz, where targets are measured in single-digit miles rather than hundreds, the time between firing and impact is effectively 0. Not reduced, not minimized, 0. By the time a boat's threat warning system registers the HELIOS beam, the energy has already arrived. By the time the helmsman attempts an evasive turn, the engagement is already over, The window that Iran spent decades trying to exploit simply does not exist against a directed energy weapon moving at the speed of light. But speed is only half the story. The second half is what HELIOS does to the magazine problem, the constraint that swarm doctrine was built to defeat. HELIOS does not have a magazine. Its engagement capacity is not limited by any count of physical missiles stored in launch tubes. It is limited only by the ship's electrical power generation. An Arleigh-Burke-class destroyer produces somewhere between 7 and 12 megawatts of electrical power from its 4 gas turbine generators. HELIOS draws only a fraction of that capacity per engagement. The beam can repoint between targets in fractions of a second. The dwell time required on each individual drone or boat is measured in seconds. A swarm of 150 drones, the kind of massive coordinated launch that could previously push a destroyer toward the edge of its interceptor supply and force a combat withdrawal, now represents approximately 150 sequential 1-second engagements for HELIOS. The operational cost of each engagement is roughly $1 in electrical power. Iran spent $3 million on that hypothetical attack. America spent $150 defending against it. The economic asymmetry that made swarm doctrine viable for 30 years has been reversed by a factor of roughly 20,000 to 1 in America's favor. The trap Iran spent 3 decades constructing just became the most expensive strategic miscalculation in its military history. Now consider what this means for the geography itself. The strait is only 21 nautical miles wide. Iran deliberately positioned its fast attack boat bases close to the shipping lanes, hidden in coastal cave networks along its shoreline. Short transit time from those hidden bases to the commercial corridors was a built-in feature of the swarm strategy. Launch quickly, engage rapidly, retreat before a conventional response could organize. That proximity was an advantage. That proximity is now a liability. The moment an Iranian fast attack boat leaves its concealed berth and enters international waters, it enters the HELIOS engagement envelope. There is no staging area outside the beam's coverage where the fleet can assemble, coordinate approach vectors, and prepare a synchronized multi-axis attack. The strait is 21 miles wide. The engagement envelope covers the strait boundary to boundary. The home ground that gave swarm doctrine its operational advantage has become the laser's coverage zone. There is also a detection dimension that Iranian planners did not anticipate. Iran invested heavily in shaping the hulls of its fast attack boats to scatter radar returns rather than produce clean reflections. Radar cross-section reduction is technically demanding, expensive, and it took years of engineering work. The result was genuinely effective at complicating fire control solutions for radar-guided interceptor missiles. HELIOS uses radar for initial detection at long range. But for the actual engagement, it transitions to electro-optical and thermal imaging systems. And here lies the problem that 30 years of hull-shaped investment did not address. A fiberglass boat moving at 50 knots through the warm waters of the Persian Gulf, powered by a high-output engine, produces a significant infrared thermal signature. That signature is entirely independent of the boat's radar cross-section. You can shape a hull to scatter radar energy to the limits of your engineering capability, and it will do absolutely nothing about the heat pouring off the engine and drive system. Radar cross-section reduction and thermal signature reduction are completely different engineering problems requiring different solutions and materials. Iran optimized for one, HELIOS engages through the other. 3 decades of sophisticated naval design investment to defeat radar-guided tracking has been rendered irrelevant by a system that does not need the radar return the hull was shaped to deny. The HELIOS deployment does not exist in isolation. It becomes even more strategically significant when understood as one half of a paired capability. The Strait of Hormuz is not only a surface threat environment. Iran's military doctrine operates in 2 domains simultaneously. Above the waterline, fast attack boats, drones, and cruise missiles. Below the waterline, Ghadir-class submarines, small diesel-electric vessels specifically designed for the shallow water environment of the Persian Gulf, where depths run between 30 and 60 meters. Small acoustic signatures, quiet diesel-electric propulsion, and the constant noise of commercial shipping traffic providing acoustic cover. Lamprey is Lockheed Martin's extra-large unmanned undersea vehicle, an autonomous system specifically designed for shallow water operations. Its acoustic signature is engineered to blend into the ambient noise of commercial shipping. It can track and maintain contact with submarines, including the Ghadir boats that Iran has positioned as its underwater threat layer. HELIOS addresses everything above the waterline. Lamprey addresses everything below. Together, operating from the same hull, they represent the first integrated above and below waterline defensive solution, specifically calibrated for the exact threat environment. Iran's swarm doctrine was built on the premise that simultaneous multi-domain threats exceed any single defensive architecture's capacity. The HELIOS and Lamprey combination is a direct operational answer to that premise in both domains at once. The integrated response that Iran's smartest military planners designed their entire strategy to prevent from ever existing has now arrived. Honest strategic analysis requires acknowledging what HELIOS cannot do. Atmospheric conditions matter. In heavy rain, dense sea spray, or smoke, the beam's effective power density at operational range can be reduced. It is not a defeating limitation, but it is a weather-dependent factor that planners must account for, and one that Iranian engineers have noted. There is also a thermal management constraint. Sustained extremely high-tempo engagement against a massive swarm could approach the system's cooling threshold. Both limitations are real. Neither is currently exploitable by the organization that faces this weapon. Iran's drone inventory has been significantly degraded by weeks of conflict and by restrictions on component supply chains. Generating a swarm large enough and sustained enough to exploit Helios's thermal constraints would require capabilities Iran currently does not possess. If you have made it this far, you are clearly someone who wants to understand the real story behind the headlines, not just the surface noise. Subscribe right now and join a community that thinks deeper. The next part of this video gets even more revealing. The IRGC's institutional response to the HELIOS confirmation is itself strategically revealing. Within hours of the deployment becoming known in Iranian military intelligence channels, the information apparatus produced public statements, calling the system overrated, untested in real combat, and susceptible to countermeasures already in development. Read those 3 responses carefully. Each one communicates something the IRGC did not intend to disclose. Calling a threat overrated is precisely what an organization does when that threat is significant enough to require actively managing the psychological impact. If HELIOS were genuinely irrelevant to Iranian operational planning, there would be no urgent public response to its deployment at all. The speed and specificity of the dismissal is evidence of exactly how seriously the system is being assessed. The claim that the system is untested in real combat is technically accurate in a narrow sense, but ignores the extensive testing program. Systems are not deployed to the world's most contested waterway as their first operational test. The deployment decision reflects confidence derived from a comprehensive testing record conducted under replicating conditions. The claim that the system is susceptible to countermeasures currently in development is the most revealing statement of the 3. It simultaneously admits that those countermeasures do not currently exist in operational form against this specific deployed system. Iran is at the very beginning of that calibration process on the day the system arrives. The diplomatic timeline does not provide the engineering time required to close that gap. Consider the strategic messages delivered. To Iran, the economic exchange ratio advantage that swarm doctrine provided has been addressed in the specific theater it was designed for. The mathematical lever that made asymmetric warfare economically viable against the most powerful navy in history no longer functions. To the IRGC hardline commanders, the next engagement they are calculating will encounter capabilities they were not designed to counter. To Beijing, Chinese military planners have been observing the Hormuz conflict as a live validation environment for their own doctrine. The People's Liberation Army has constructed its naval strategy around the same foundational economic logic that Iran employed. Saturate the defense, exhaust the interceptors, find the withdrawal window. The DF-21D and DF-26 carrier killer missiles share the same underlying assumption about exchange ratio economics. HELIOS, operational confirmation in a live contested waterway, is a direct message that those economics have been inverted. On June 7, 2026, Iran's strategic position reflects the compound effect of every development this conflict has produced. The conventional naval force is gone. The missile infrastructure coordinates are in American targeting databases. The coastal fast attack network has been substantially degraded. The proxy network across the region is dissolving. 73 tankers carry oil going nowhere. Food inflation has reached triple digits. Hard currency reserves are being rationed. The one remaining economic advantage, the exchange ratio mathematics of swarm attack, has been reversed by a deployed operational system. $1 per engagement. That is what it now costs to defeat the swarm that Iran built 3 decades of military doctrine around. The Strait of Hormuz, the leverage point over the global economy and defense against the United States, will never look the same. The organization that built its entire strategic identity around asymmetric economics is doing the math right now on what remains. The math changed. The question is no longer whether the old strategy works, because it clearly does not. The question is whether the people making the decisions understand what changed in time to do anything about it. If this breakdown helped you see the bigger picture, leave a comment with your take and share this video with someone who needs to hear it. Subscribe, because the next development in this conflict will make today's analysis look like the opening chapter. The future of naval warfare was just rewritten in a single night, and most of the world has not realized it yet.